Hello guys, welcome to the next lecture of Unit 1 IAS Physics. In the previous lecture, we were discussing about the displacement time graphs and they were very good. Today, we'll be starting off with the velocity time graphs, the graphs of velocity against time. Again, these are exceptionally important concepts, so I'm pretty sure that you understand them before anything. Okay. Now, when it comes to velocity time graphs, guys, velocity time graphs are very important. There are multiple things that you need to remember that if there is a velocity time graph, the area under the graph of velocity against time actually gives us displacement. So area gives us displacement that we have discussed in the previous lesson as well. And the gradient, the y2 minus y1 over x2 minus x1 gradient gives us, or slope gives us acceleration. So the gradient gives us acceleration. These are the two things that you need to remember, that the area of a velocity time graph gives us displacement and the gradient gives us acceleration. Achha. When it comes to velocity time graphs, there are again 8 graphs that we need to remember, and they are just basic understanding of what velocity time graphs actually look like. And from then and there, inshallah, we'll be doing remaining concepts of combined graphs and how can we cover that. And in the coming lectures, we'll be doing that. First of all, today we'll be starting off what the velocity time graph generally is. So just for the sake of understanding what a velocity time graph is, so when it comes to object being in rest, the velocity time graph looks like this. It's a straight line with zero gradient. That means the object is not having any acceleration. So the gradient is zero, and basically the gradient is zero. That means there is no acceleration. And since the graph is on the x-axis, this shows that there is no velocity as well. It's a velocity time graph. Previously, they were like displacement times and other graphs, but this is a velocity time graph. You need to realize that on the y-axis, we have got velocities values. So this is the graph of rest. Moving on. Well, when it comes to constant velocity, or you can say uniform velocity, there are two case scenarios. For example, if let's say there's an object and that object is you guys, and you guys are moving to the right. You're moving to the right and moving with a constant uniform velocity. The graph is going to look something like this. So it's like a positive, velocity is positive. This shows that you have got uniform velocity and in the positive direction. I'll just write positive direction because it's already uniform velocity, and this is positive direction. That means if you're taking right side as positive, you're moving to the right with a uniform velocity. The velocity is not changing, you're not accelerating, you're not decelerating, but you're moving with a constant velocity. In case you're moving to the left with a uniform velocity, the graph is going to look something like this. So it's going to be negative direction, but still you're going to be moving in a uniform velocity. Your rate of change of displacement is constant. You're actually moving with the same velocity, or you can say the same speed in the negative direction. You're not speeding up, you're not slowing down. So these are the graphs for uniform velocity in like AS level. Moving on. Now there comes uniform acceleration. Uniform acceleration actually means that the object is going to increase its velocity at a constant rate. So for example, if I were to make you understand this concept, if you guys are accelerating from rest to the right hand side and you're speeding up, you're getting faster, but with a uniform rate. For example, you started off with 0, go to 10, 20 meters per second, 30 meters per second. If you remember the first lecture, we did the concept of uniform acceleration and non-uniform acceleration. That concept we are discussing right now. If somebody is moving with velocity 0 meter per second, gaining it to 10 in first second, then 20, then 30, Each second, the velocity gained by the object is like 10 meters per second. Rate of change of velocity is uniform. The graph is going to be a straight line with a uniform gradient. That's acceleration. But what if the object is moving to the left, exactly doing the same thing, but object is moving to the left, the object would be gaining its velocity. But in negative direction, the velocity's increase is going to be somewhere like this. It's going to be from 0 to negative 10, negative 20, negative 30. This negative sign indicates that object is gaining its velocity, but the object is gaining velocity in the negative direction. Other than that, there's no other significance of this negative sign. Rather, this negative sign actually indicates that the velocity is gaining, like it's uniform acceleration in the positive direction and uniform acceleration in the negative direction. Velocity time graph actually involves direction. So if let's suppose you're moving to the right and you're gaining, you're accelerating, so uniform acceleration in the positive direction, and if you're moving to the left, you're gaining velocity, uniform acceleration in the negative direction. So you need to actually understand this, and you need to actually come like 100% understand the concept of uniform accelerations. Moving on. Well, then we have got, if for example, non-uniform increasing. Object starts from 0 to 10, then gain speeds to 30, then to 80. Each second, the velocity is increasing, but the rate at which the velocity is increasing is also increasing. So object is getting faster, that's a fact, but with that being faster, the rate at which it is getting faster is also increasing. So the graph of increasing acceleration somewhat goes like this. The gradient of velocity time graph gives us acceleration and the gradient increases. So this is basically the graph of increasing acceleration. Increasing acceleration in positive direction. These are all part of your examinations. There's nothing like you have to understand this, okay? Then we have got, if let's say the object starts from 0 and it's moving to the left, that means the velocity's increase is going to be negative. So this is also increasing acceleration, but in the negative direction. Direction is very important when it comes to velocity time graphs. These are not speed time graphs that you used to discuss in your IGCSE. These are rather velocity time graphs that you have to actually understand what is happening over here. So these are basically, this means that the object is accelerating in the negative direction. And yeah, the gradient is also increasing, negatively increasing gradient. And since the velocity time graph's gradient gives us acceleration, so it's increasing acceleration in the positive direction, and this is increasing acceleration in the negative direction. Increasing acceleration in negative direction. Moving on. Now let's discuss a decreasing acceleration. So the decreasing acceleration goes like this. The gradient is decreasing and eventually let's assume the object comes to the constant velocity. So this is actually basically, let's say if the object starts from 0, goes to 10, to 18, to 22. So we would realize that although the speed is increasing each second 10, then 8, and then speed is increasing by 6. So the graph is increasing, the velocity is increasing, you can see, but initially the change in velocity is higher compared to the next step. So this is decreasing acceleration in the positive direction. So this basically is decreasing acceleration in positive direction. So decreasing acceleration actually refers to your acceleration is decreasing. Initially you were getting faster at a faster rate, but still you're getting faster, but the rate at which you're getting faster is decreasing. That's decreasing acceleration in a positive direction. Similarly, if I were to draw a graph of decreasing acceleration in the negative direction, this would have been very simple again. This is going to be the shape of the graph in the negative quadrant. So let's assume if the object is going from 0 to negative 10, negative 18. Although the velocity's magnitude, you can clearly observe it's increasing, but since it's in negative direction, so it's going to be decreasing acceleration in the negative direction. Other than that, there's nothing important over here. Just rather the object is moving to the left or it's moving to the right. These are first 5 graphs. Well, moving on. Now there are 3 more graphs. First is important, very important. This one's very important, but the other ones, they're like slightly less important, but okay, they're still part of our syllabus. First of all is uniform deceleration. So deceleration means the object's magnitude of velocity is going to decrease. So initially you can clearly observe that the velocity is going to go down, the velocity is going down. Each second the velocity is decreasing at the same rate. This shows uniform deceleration. For example, object started at 40, reduced down to 30, to 20, to 10, and then eventually to 0. So each second the velocity is going to decrease by a -10 value. This is uniform deceleration. From positive, like the velocity is positively reducing, that means object is moving in the positive direction, coming to rest. All right, this actually shows, like, let me just draw it in front of you. For example, you're moving to the right and then you eventually goes to like rest over here. So since you are moving in the positive direction, your velocity is positively reducing to eventually reducing to 0. If you would have been going the other way around, let's say to the left, and your like speed is decreasing and eventually coming to rest, that means in initial part of the journey you had a negative velocity and then it came to rest. So if you were moving to the left, you would have a negative velocity that would have reduced. The magnitude of the velocity is definitely going to reduce. The object is definitely slowing down. But since the object is going in this direction, like from the left side, like it's moving to the left, that means initially the magnitude of velocity was very high, but it was negative because velocity, whatever the direction of motion is, that is the direction of velocity. So if I'm moving to the left, my velocity cannot be positive. My velocity will be negative if I'm taking left as a negative direction. So this is very important concept that every second the velocity will be reducing and eventually coming to 0. Moving on, so this is uniform deceleration in positive direction, and this is uniform deceleration in negative direction. Well, similarly, we have got 2 last graphs. I'm not going to take a lot of your time. They're like asked in your examinations, rarely asked, but the graph goes like this. This is increasing deceleration. Graphs, increasing deceleration actually means initially, let's say if this is 100, the speed goes down to 90, then eventually it goes down to 50 and then to 0. So first second, the speed reduced by -10. Next, it reduced down to -40, then by -50, sorry. So initially the object slowed a little bit, but then a little bit more, and then even more than that. So this actually is what we call it, increasing deceleration. So this is increasing deceleration curve. Object is like moving, slowing down, but initially it slowed down a little bit and then a little bit more and then a little bit more. So it's increasing and it's deceleration. So same goes for the negative side as well, because velocity can be negative, can be positive, depends upon the motion. So this is like increasing deceleration in the positive and in the negative direction. Last, we have got decreasing deceleration. That graph goes somewhat like this. It's gonna be, yeah, this is very rare. This one, last one is very rare. This concept is very challenging as well. So like not a lot of times this is asked in the examination. But again, since you are a Sir student, I would recommend to like understand the concept. If your concepts are clear now, in case if your concepts are clear, your crystal clear concepts, I am damn sure there's nothing that could be going wrong other than like the paper will be all going very well. Because if the concepts are not clear, then you will like be struggling. What is the gradient giving? What is happening in that graph? What is like happening or something? So we'll be doing next lectures. We'll be discussing how to change these graphs and everything. But I'm pretty much hoping that you understand the concepts. Okay. So initially, if the velocity was 100 and then 100, it reduces down to, let's say, 50. And then from 50, it reduces down to 30 and then to 20. So initially, first second, it reduces by -50, then by -20, and then by -10. So you can clearly see that initially the deceleration was more, so and then the deceleration magnitude reduces. So this is decreasing deceleration. Decreasing deceleration. And this is the positive direction and this is the negative direction. So in the negative it's going to be like somewhere like this, -50, -30 and -20. So that's pretty much all we have to learn about the velocity time graphs in general. In the next lecture, we'll be discussing how we're going to be doing some related graphs. We're going to be reviewing acceleration time graphs. It's very simple. So we'll be doing acceleration time graphs as well. And yeah, after that, inshallah, we'll be doing questions regarding this. See you in the next lecture. Take care, guys. Hello, guys. This is Sir Mahad Amer, and welcome to another lecture. Since you're enjoying the lectures, just wanted to inform you that there are premium batches going on. That is a direct way to get A's and A stars. It has got some exclusive content that is not generally available neither on the website nor on the YouTube. So you can join the batch to get your grade.